Hi, let us understand Apache Zookeeper. It's a highly reliable distributed coordinator where it's going to facilitate the coordination activity in any distributed architecture. Nowadays, we do have n number of components which works in a horizontal distributed fashion. Say for example name node where I'll be having n number of worker machines as well as I'll be having a master machine. Say for example HBase. I'll be having a number of worker machines, I'll be having a master. And even Kafka that works with n number of machines. To do all the coordination in all this distributed architecture, I need a dedicated coordinator, especially for the big data ecosystem, and that should be very highly available. So it's going to act like a centralized service to maintain the configuration information. So what is that? All the configuration in the entire distributed architecture can be maintained within the Zookeeper and it can be made very highly available. So it's going to act like a naming system as well. Let's have some small understanding on the background of Apache Zookeeper. It was developed as a part of HBase to do the coordination of high availability of the master. HBase can exist with n number of masters coordinating to provide very high availability. Even if one master goes down, there will be another master which will be taking care of it. Let us see with an example. Say I do have a number of worker machines and all the worker machines will be controlled by the master. In case if the master fails, all the workers will stop responding. The coordination would get stopped. To have high availability, what I will be doing, I will be having n number of masters. And whenever I have n number of masters, all the workers simultaneously they cannot report to all the masters. At any point of time, only one master can take charge. If the master goes down, there has to be a coordination. A signal has to go to all the worker machines saying this master is down and you need to start reporting to the other master. If the master goes down, then all the workers needs to be requested to communicate to the other master and the coordination should happen by a component which is going to oversee the entire architecture or the entire systems. And that's where the Zookeeper comes into picture. It was developed as a dedicated service within the HBase and later it was realized it's a very good component. So it was forked and made as a separate project within Apache. Now Zookeeper is a separate top level project. Now this is being used by Kafka, HDFS, HBase, n number of components to do the coordination. It uses the Zookeeper. So how Zookeeper works? Since Zookeeper going to do the coordination, it has to be very highly available and that works as a quorum. What is quorum? An odd number of systems will be coordinating the entire activity. So if I have 5 systems, within that one will be elected as a leader. So all the changes will be coordinated by the leader and all the other followers will be following the changes. So even if any one system goes down, there will be the other system that will be doing the coordination. And this we call it as a quorum. And Zookeeper works as a quorum and internally it maintains hierarchy of data. So what it does, let's assume I'm going to maintain the database information for production and for QA environment. For production, I'm going to maintain the database. So I'll be having the nodes like for database, this is the IP address. And let's say the name node, it is running in this specific machine. The same way, I'll be maintaining another hierarchy for QA environment. What is going to be the IP address? So I'll be having a tree like this. And within the tree, I'll be having a number of nodes. Production, that's going to have where the database, where the name node is running. And for QA environment, where the database, where the name node is running, I'll be having a different IP address, whatever that is corresponding to that particular stage. The advantage of having such hierarchy is wherever I'm going to do the configuration, I'll be providing this specific configuration. See, if I want to access the production database, I'll say production and name node. So what would happen, whatever the value corresponding to the name node within the production leaf, and that would be the value. So I don't need to hardcode this specific IP address in all other services configuration file. So whenever a configuration file referring to this particular configuration, it will get referred to that specific IP address. Let's assume the name node got failed and or the name node is getting upgraded, a new name node is brought into picture and its IP address is let's say 65. All I need to do is I need to make the change within the Zookeeper. And all the services which is getting referred to that specific node, it will start getting that new IP address, and it will be very easy to deploy any new change as well as to do the configuration change in an anonymous way in the entire distributed architecture. I don't need to worry about who are all using it, and I don't need to find out and inform all the configuration change to everyone and make sure they have made the configuration changes. So it's going to maintain the configuration at a centralized location. Any configuration change, I can do it in a centralized location that is within the Zookeeper, and whoever is referring to it, they will be getting always the updated configuration change. And the Zookeeper itself, it runs as a quorum, so it's going to be very, very highly available, as well as it fits very well with many big data ecosystems like Kafka, HDFS, HBase. It's very, very highly available as well as reliable, and it works in a distributed fashion.